Hi student, this is Gukumar, 11th standard mathematics, chapter number 3, continuation of exercise 3.4. Now problem number 17. Prove that totally 4 subdivisions are there. Can do one by one. Now subdivision number 1. Subdivision number 1, consider that LHS sine of a plus b into sine of a minus b. Sine of a plus b formula, sine a cos b plus cos a sine b. Sine of a minus b formula, sine a cos b minus cos a sine b. That is equal to, here sin a cos b, here also sin a cos b, here cos a sin b, here minus cos a sin b. What form it is? A plus b into a minus b. A plus b into a minus b identity, you know that. A plus b into a minus b identity is a squared minus b squared. This entire expression is a, that is sin a cos b the whole square minus b, that is cos a sin b, cos a sin b the whole square. So a square minus b square. Now this square is common for both sin a and cos b, that is equal to sin squared a cos squared b minus cos squared a sin squared b, cos squared a sin squared b. Now look at the RHS. In RHS we have only sin, no cos at all. So that this cos to be eliminated. So I am retaining sin squared a, cos squared theta, you know the formula, 1 minus sin squared theta. Instead of theta we have b minus, like that cos squared a can be replaced by 1 minus sin squared a into sin squared b. Now usual multiplication, sin squared a into 1 is sin squared a minus sin squared a sin squared b minus 1 into sin squared b is sin squared b minus into minus plus sin squared a sin squared b equals minus sin squared a sin squared b plus sin squared a sin squared b both get cancelled, sin squared a minus sin squared b minus sin squared b, that is equal to RHS. Look at that RHS, sin squared a minus sin squared b. Subdivision number 1 is over. Now subdivision number 2, consider cos of a plus b into cos of a minus b. Subdivision number 2. Consider cos of a plus b into cos of a minus b. Cos of a plus b formula, cos a cos b minus sin a sin b. Cos of a minus b formula, cos a cos b plus sin a sin b. Then once again, what form it is? A minus b into a plus b. A minus b into a plus b identity, again I write, or a plus b into a minus b, that is equal to a square minus b square. This is a, that is cos a cos b the whole square minus b square, this is b, sin a sin b the whole square. So this square is common for cos a and cos b. It can be written as cos squared a into cos squared b minus sin squared a into sin squared b, sin squared a into sin squared b. That is equal to cos squared a. Look at that second subdivision. We have cos squared a and sin squared b. We have cos squared a and sin squared b. So we have to retain cos squared a and sin squared b. Cos squared a and sin squared b both to be retained, these two to be changed. So cos squared a I am retaining. This cos squared b can be replaced by 1 minus sin squared b, because cos squared theta equals 1 minus sin squared theta minus sin squared a, that is 1 minus cos squared a. Because sin squared theta equals 1 minus cos squared theta, this sin squared b write as it is. Now usual multiplication, cos squared a into 1 is cos squared a minus cos squared a sin squared b minus 1 into sin squared b is sin squared b, minus into minus plus cos squared a sin squared b. Plus cos squared a sin squared b minus cos squared a sin squared b both get cancelled, getting cos squared a minus sin squared b. Cos squared a minus sin squared b. It is proved. Then from this result we have to prove the another result, cos squared b minus sin squared a. Look at that, cos squared b minus sin squared a. How to prove? Cos squared b minus sin squared a, so that this cos squared a can be written as 1 minus sin squared a minus sin squared b, that is equal to 1 minus cos squared b. That is equal to 1 minus sin squared a as it is, minus into 1 minus into minus plus cos squared b. Plus 1 minus 1 get cancelled, that is equal to cos squared b minus sin squared a. That is also true. Hence proved. Now subdivision number 3. What is here? Cos squared b minus sin squared a. Here cos squared a minus sin squared b. Here cos squared a minus sin squared b as well as cos squared b minus sin squared a. Now subdivision number 3, consider that LHS sin squared a plus b minus sin squared of a minus b. Subdivision number 3, sin squared of a plus b minus sin squared of a minus b equals, what form it is? Sin squared a minus sin squared b. Sin squared a minus sin squared b, you can write like this. Instead of already we have capital A and B in the question, I write like this. We know that sin squared x minus sin squared y, that is equal to, look at that, sin squared x minus sin squared y. Instead of a and b, I consider x and y. Sin squared a minus sin squared b equal to sin of a plus b into sin of a minus b. So sin squared x minus sin squared y, that is equal to sin of x plus y into sin of x minus y. Sin of x plus y into sin of x minus y. Here x that is equal to a plus b, and y that is equal to a minus b. Substitute over here. Sin x plus y, x that is a plus b, plus y that is a minus b. Again sin x minus y, x that is a plus b minus y that is a minus b. Now eliminate the brackets. Sin right as it is, a plus b plus a minus b plus a minus b. Sin of a plus b as it is, minus a minus into minus plus b, minus a plus b, plus a minus a, here plus b minus b get cancelled, a plus a 2a, b plus b 2b. So sin 2a sin 2b, that is equal to sin 2a into sin 2b, that is equal to RHS. We have proved. So subdivision number 3 is over. Now subdivision number 4. Consider that LHS. We have cos 8 theta into cos 2 theta. We have cos 8 theta into cos 2 theta. I write 8 theta and 2 theta as cos of 5 theta plus 3 theta into cos of 5 theta minus 3 theta. 5 theta plus 3 theta, that is 8 theta. 5 theta minus 3 theta, that is 2 theta. Why I am considering 5 and 3? And look at that RHS. We have 5 theta and 3 theta only have taken. So that I have taken 8 theta as 5 theta plus 3 theta and 2 theta as 5 theta minus 3 theta. So what form it is? Cos of a plus b into cos of a minus b. Cos of a plus b into cos of a minus b. We know that cos of a plus b into cos of a minus b, that is equal to, look at that result, we have cos squared a minus sin squared b. Here it is. What's the formula? Cos squared a minus cos of a plus b into cos of a minus b. Two different formulae there. You consider this one, right? Suppose you are given cos squared 3 theta minus sin squared 5 theta, you can consider this formula. Both can be applied. Particularly for subdivision 4, you have to consider this alone, right? Cos squared a and sin squared b. Which one is a? 5 theta. Write the formula first. Cos squared a minus sin squared b. A plus b. A plus b. Which one is a? 5 theta. And b, that is 3 theta. Substitute. You can get the result. Cos squared a, that is 5 theta, minus sin squared b, capital B, that is 3 theta. That is equal to RHS. Look at that, cos squared 5 theta minus sin squared 3 theta. Here it is. Over. All the 4 subdivisions of problem number 17 are completed. Then I'll be teaching the problem number 18 in the next video. Thank you, children.